Gemini Humanoids are here, and some of the demos look like CGI. I'm talking origami folding, a robot packing a snack into a Ziploc bag, a humanoid grabbing objects it's never seen before, while you talk to it like it's a coworker. And if you've been on the internet lately, you've probably seen the same headline vibe. DeepMind just built a humanoid brain. Google's Gemini is about to replace your job. Robots are basically done cooking us. Yeah, not exactly. Because what people think Gemini Humanoids are, and what DeepMind actually announced, are two very different things. And the difference matters, because it's the difference between a flashy demo and a deployable robot workforce. So today, we're breaking this down in the same order your brain is probably processing it. 1. What people think this is. 2. What DeepMind actually announced. 3. The demo moments that look unreal. 4. The hidden limitations. 5. The real bottlenecks. Hardware, data, safety, cost. 6. What this changes in the next 12 to 24 months. And yes, we're ending with the real reason this is scarily advanced, but still not your home robot tomorrow. Let's go. What Gemini Humanoids even means. First, quick translation. DeepMind didn't walk on stage and unveil a brand new humanoid called Gemini. Gemini Humanoids is basically internet shorthand for this. DeepMind's Gemini models are being turned into robot brains, including for humanoid bodies. And DeepMind has been building toward this for years. You might remember RT-2 back in 2023. That was a big step toward robots that can take vision and language and turn it into actions. But in March 2025, DeepMind dropped the bigger headline: Gemini Robotics and Gemini Robotics-ER, models built on Gemini that are designed to operate in the physical world. And then, in late 2025, they started shipping more pieces of the puzzle, smaller, on-device robotics models, and even an SDK for developers. And as of January 2026, Gemini is now showing up in real humanoid partnerships, including Boston Dynamics' next-gen Atlas work. So yeah, Gemini Humanoids is a vibe. Now let's clean up the myth first. 1. What people think this is. Here's what the comment section thinks is happening. Google made a humanoid that can do anything. It's ChatGPT, but with legs. It's basically Optimus with a PhD. And to be fair, the demos encourage that vibe. The robot looks calm. It follows instructions. It adapts when something changes. It feels like it understands. So people jump to the conclusion that we've hit the final form. General-purpose humanoid worker. Show up, learn job, do job, repeat forever. But that's not what DeepMind actually shipped. Because there's a key difference between a humanoid robot body and a robotics foundation model that can control many bodies. And that brings us to the actual announcement. Moving on. 2. What DeepMind actually announced. DeepMind introduced two main pieces. A. Gemini Robotics. This is a vision language action model. Translation: it takes what the robot sees, plus what you say, and outputs actions, like actual robot movements. DeepMind framed the whole goal around three qualities. Generality, work in new situations. Interactivity, respond to you and changes fast. Dexterity, hands that can do human-ish tasks. And they made a big claim. On average, Gemini Robotics more than doubles performance on a generalization benchmark compared to other state-of-the-art vision language action models. Not slightly better, not a nice improvement, more than doubles. That's why people are freaking out. B. Gemini Robotics-ER. ER stands for Embodied Reasoning. This one is more like spatial understanding and planning and code generation. DeepMind describes it as a model that can do the steps needed for robot control, perception, state estimation, planning, and more. And they claim 2 times to 3 times success rate compared to base Gemini 2.0 in an end-to-end setting. And here's the part that tells you they're serious about going beyond demos. They talk about plugging into low-level safety-critical controllers, collision avoidance, contact force limits, stability, because robots aren't just smart. They're dangerous if they're wrong. Now, the most important detail, the one that makes this humanoid. DeepMind trained primarily on a dual-arm system called Aloha 2, but they show it can adapt to other robot bodies, including Franca arms, and even be specialized to a humanoid like Aptronik's Apollo. So this is not one robot. This is a brain that can drive different robot bodies. And once you see that, the demo moments make more sense. 3. The demo moments that look unreal. Okay, let's talk about why the internet is calling this scary. Moment number 1. The dexterity flex. DeepMind explicitly calls out tasks like origami folding and packing a snack into a Ziploc bag. If you've ever tried doing anything with cheap plastic bags, you already know. That's not robot hard. That's human annoying. So seeing a robot do it at all is wild. Moment number 2. Replanning mid-task. DeepMind describes a key behavior. If something slips or someone moves an item, the system quickly replans and carries on. That's the difference between a robot that's pre-programmed and a robot that can survive reality. Because reality is basically, oops, every 5 seconds. Moment number 3. Natural language, like a normal person. They emphasize that it can respond to instructions phrased in everyday language, even different languages. Not execute protocol 7. More like, put that over there. No, the other one. Actually, stack it. That's a huge deal because humans don't speak in command line syntax. Moment number 4. The humanoid demo energy. There have been demos and reports of Aptronik's Apollo doing tasks with unfamiliar objects, handling odd shapes, responding to spoken instructions, adjusting when things move. And then, the industrial chess move. In early 2026, Boston Dynamics announced a partnership with Google DeepMind to bring Gemini Robotics-style intelligence into Boston Dynamics robots, including humanoid Atlas work. And Wired described the concept as Gemini helping Atlas do tasks like sorting components on auto factory floors. So yes, the demos look unreal. But now, we do the part the internet hates, the limitations. 4. The hidden limitations. Here's the reality check. A robotics demo can be genuinely impressive and still be far from deployable, because the gap between works once and works every time is basically the entire industry. Let's hit the main constraints. Limitation number 1. Controlled worlds. Even when robots adapt, they're usually adapting inside a curated environment. Known workspace, known lighting, known object types, known safety constraints, known recovery options. And yes, DeepMind is pushing generalization, but the real world is a chaos generator. A factory is not your kitchen. And your kitchen is not your friend's kitchen. And your friend's kitchen is not a restaurant kitchen. Limitation number 2. Hands are still the final boss. DeepMind can give robots better brains. But if your grippers can't consistently pinch, rotate, and apply the right force without crushing or dropping things, congratulations, you have a very smart robot that is still bad at opening a bag of chips. Even the reports that hype these demos admit it. Today's systems still struggle with finesse tasks like fully sealing a Ziploc bag consistently. Limitation number 3. Data is expensive. Unlike language models that can learn from the internet, robot learning needs interaction data, real movements, real consequences, real physics. You can't scrape force feedback from Wikipedia, which is why the on-device model detail is important. DeepMind's robotics on-device approach reportedly can adapt to new situations with as few as 50 to 100 demonstrations. That's impressive, but also reveals the truth. You still need demonstrations, you still need data, you still need training time and validation. And now for the big one. Limitation number 4. Safety isn't optional. DeepMind talks about layered safety, from low-level motor safety to high-level semantic reasoning. Because when a robot messes up in a browser tab, you refresh the page. When a robot messes up in the physical world, something breaks, or someone gets hurt. So even if a model is smart, it has to be safe in repeatable, verifiable ways. And that brings us to the real bottlenecks. 5. The real-world bottlenecks. If you want the honest forecast for humanoids, it comes down to 4 walls. A. Hardware. Humanoids are a power budget problem. Actuators have limits, batteries have limits, gearboxes wear out, motors heat up, hands need precision and durability at the same time. In a lab, you can baby the robot. In deployment, the robot has to do the job while being bumped, dusted, moved, and maintained. And maintenance is not a footnote, it's the business. B. Data and generalization. Even with Gemini-level world knowledge, physical skill is physical skill. A model can understand what a mug is, but grasping a mug by the handle depends on geometry, friction, and timing. DeepMind's Robotics-ER example literally describes the model inferring a two-finger grasp on a mug handle and a safe trajectory. That's powerful, but scaling that across the near-infinite variety of objects in the world is a massive data and validation problem. C. Safety and verification. This is the killer that people underestimate. To deploy in real places, you need predictable behavior, safe failure modes, consistent recovery, and proof that it works reliably, not once, not 10 times, more like 10,000 times. And if you want robots around humans, now you're adding risk tolerance, compliance, and liability, which means the rollout will naturally start where it's safer. Controlled industrial environments, repetitive logistics tasks, fenced-off work zones, not your living room with pets, kids, and fragile objects. D. Cost. Even if Gemini makes robots smarter, smart robots aren't automatically cheap robots. Sensors, compute, motors, and safety systems cost money. Then you add installation, training, monitoring, maintenance, repairs, support. That's why the on-device model and small and efficient enough to run on a robot matters, because cost and latency are major blockers. And yes, DeepMind is attacking that, but it's not instant. 6. What this changes in the next 12 to 24 months. All right, what's the real takeaway? Here's what changes soon, and what probably doesn't. What changes? 1. Faster robot learning across bodies. The multi-embodiment idea is huge. If one model can transfer skills from a dual-arm platform to a humanoid without starting from zero, that accelerates everything. 2. More industrial pilots that look like science fiction. Not in homes, in factories. The Boston Dynamics and DeepMind partnership is a signal. The best robot bodies want better brains, and the best brains want real robot bodies. Expect more robots doing useful work headlines in warehouses, manufacturing, and logistics. 3. On-device autonomy becomes normal. DeepMind rolling out an on-device model and an SDK suggests the ecosystem is moving toward real deployment constraints, offline operation, safety restrictions, developer tooling, evaluation frameworks. That's how you go from demo to platform. 4. Robots start thinking out loud. DeepMind's newer messaging around thinking before acting and making decisions transparent in natural language is not just a cute feature. It's about trust. It's about debugging. It's about making robots usable by normal humans. What probably doesn't change yet. You're still not getting a general-purpose humanoid in your home that does everything. Not because the AI is dumb, but because the real world is brutal. The bottleneck is still deployment, hardware reliability, safety validation, and cost. So yes, Gemini humanoids are scarily advanced, but the real revolution isn't a robot that can do one trick. It's a robotics brain that can generalize, interact, and transfer skills across bodies. And that's the closest we've seen to a real foundation model for robotics. Wrap and call to action. So, what do you think? Is DeepMind's Gemini Robotics the beginning of robot employees? Or is it another round of brilliant lab demos that take 5 years to become real products? And here's the real question. Would you rather see these humanoids roll out in factories first, or would you trust a version 1.0 in your home? Let us know in the comments. And if you want more breakdowns like this, AI, robots, and the stuff that's about to reshape daily life, you know what to do. Subscribe, like the video, and I'll see you in the next one. Because the future isn't coming, it's already in the lab, and it's trying to fold origami.